In elementary school, they teach us how to apply long division, but usually they just present the steps of the process without explaining the logic behind these steps. We understand how to apply long division, but have you ever wondered why it works? What's the secret behind it? Well, today we will discover the secret together. We will derive the long division method and understand why exactly it works. So, let's get started. When we want to divide a number like 12 by 3, we're basically asking how many 3's are in 12, or in other words, how many 3's should we add up to get 12? One of the simplest ways to answer this question is to count how many times we can subtract 3 from 12. So basically, we start subtracting from the number and adding to the count. Each time we subtract a 3 from 12, we add 1 to the count. In this case, we can subtract 3 4 times from 12, and therefore 12 divided by 3 equals 4. Now this method works well for a small number like 12. But if we want to divide a large number like 336 by 3, we will have too many steps, and therefore it will take forever to figure out the answer. But luckily, we can take shortcuts in this method. For example, we can combine two steps together. Instead of subtracting 3 from 336 and adding 1 to the count, we subtract 6 from 336 and add 2 to the count. But why combine only 2 steps? Why not 10 or even 100? Well, actually, we can combine as many steps as we want. So let's try this in our example, which is dividing 336 by 3. In this case, we can combine the first 100 steps by subtracting 300 from 336 and adding 100 to the count. Then we can combine the next 10 steps by subtracting 30 from 36 and adding 10 to the count. And finally, we can combine the last two steps by subtracting 6 and adding 2 to the count. This way, we reached the final answer, which is 112, much faster by being more efficient. But the question now is, how do we maximize our efficiency? Well, the more we subtract in each step, the faster the process will be. So we take advantage of our memorization of the multiplication table to subtract as much as we can in each step. In our case, since we are dividing by 3, we use the fourth column of the multiplication table, which is the multiples of 3. So let's see exactly how we can use it in a new example. When we divide the number 795 by 3, we will treat the number 795 as the sum of 790 and 5. First, we will try to subtract as many multiples of 300 as we can from 700. From the multiplication table, we know that the largest multiple of 3 we can subtract from 7 is 6, which is 3 times 2. Therefore, we subtract 600 and add 200 to the count. In the next step, we try to subtract as many 30's as we can from 190. From the multiplication table, we know that the largest multiple of 3 we can subtract from 19 is 18, which is 3 times 6. Therefore, this time we subtract 180 and add 60 to the count. Finally, the largest multiple of 3 we can subtract from 15 is 15, which is 3 times 5. So we subtract it and add 5 to the answer. We managed to reach the final answer, which is 265, in only 3 steps. The method we just developed now is the heart of the long division method. But in the long division method, we avoid writing down what we don't really need to see in the process. For example, we don't need to write 700 plus 90 plus 5. We can just think of it without actually writing it down as a sum of 3 numbers. Now we can finally say that we actually understand long division. Not only how to apply it, but also what goes behind the scenes, what the logic behind it is. The real problem is that long division is just a drop in the ocean. Unfortunately, a lot of what we learn about math in school is steps and procedures, but without logical explanation or proper derivation. But that's not learning math. That's more like human programming. We shouldn't be computers. We should understand the logic behind what we learn. I don't want you to stop here. I want you to keep asking and seeking answers. Ask yourself, how do we extend the derivation of long division to dividing by multi-digit numbers like 37? 37 is not in the multiplication table. Do we have to find all the multiples of 37 from 0 to 9? And what about other methods in math, like divisibility tests? What's the logic behind them? Or even the numbering system that we use. Why do we write numbers using 10 symbols? Can we use more or less symbols? How do we do that? And is it better or worse? There is much more than this. You just need to ask for the logic behind everything you learn in math and search for the answer or even try to derive it yourself. Thank you for watching, and if you liked the video, please share it with your friends.